I hope I am audible.
Yes, sir. Yes, sir.
Okay. So today we will continue with the same topic. This time we will go for the Newton's backward difference interpolation technique. Okay. So in the previous class we have seen that if we have a data, let us say we have a curve which is probably like this. Okay. And we have a data of 4 points or maybe 5 points. Okay, so we have the coordinates, okay, that is x coordinate as well as the y coordinates. So we have, let us say this is p1, p2, p3, p4. Accordingly we have x1, x2, x3, x4, and this vertical lines, they are nothing but your y1, y2, y3, and this will be y4. This will be your x-axis, this will be your y-axis. So if you want to predict what will be the value of y when the x value is somewhere over here, so when the x value is beyond the data set, then it will be called as extrapolation. Okay, but if your x value is lying in between the data set, then it is called as interpolation. Okay, so in the previous class we have seen the Newton's forward difference technique. Okay, and today we will see the Newton's backward difference technique. Okay, the process of Newton's forward difference and backward difference is exactly same. Only thing is there is slight change in the equation. Okay, so I'm just going to write down the equation for you. So y now can be calculated here. Initially, in the backward difference method, it was y0. Here it is yn. That is the last value. Okay. Then we have plus, we have p times. This is delta yn. If you remember, here we have a reverse delta. The symbol is exactly reverse because this is the backward difference method, and there should not be any confusion. That's why the reverse delta is there, and this will be delta of yn. Then we have something like p is equal to p plus 1. Okay, and if you refer the forward difference method, the equation was having p minus 1, but in the backward difference method it is p plus 1 divided by, you have 2 factorial. Okay, and again it will be multiplied by this inverse delta square of yn. Earlier in the forward difference method it was delta square y0. Okay, then plus, again we have p, then p plus 1 into p plus 2 divided by 3 factorial. Then this will be delta to the power 3 y n, and then the process goes on and on and on till you have p is equal to p into p plus 1, then p plus 2, so on up to p into sorry, not p, into, in bracket, p plus n minus 1. Okay, divided by, you will be having n factorial. Okay, and then we have delta to the power n of yn. Okay, so the similar kind of equation is there for the Newton's backward difference method. Here the p value is slightly different. Okay, so p value here it is x minus xn, that is the last value, divided by h. So h remains same. H is nothing but the difference between two consecutive values of h of x. So this distance is nothing but your h. Okay, so from here to here this is h, and h will be constant. Okay, so I hope this is clear to everybody. ठीक है?
Yes, sir.
Hmm? Exactly similar. There are some minor changes in the equations. Okay, so let us take a numerical. So we are going to take the same numerical which we have solved earlier. Okay, so let us say example 1. Okay, so in the example 1 we have data of a population. Okay, so let me insert like this. Okay, so here we have year, and here we have population. Okay, so year is 1891. Okay, 1901. 1911, 1921, then 1931. I think 91, 01, 11. Okay, only this much data is there, and this was 46, 66, 81, 93, and 101. Okay, so we have this same data, same problem. Now, if you remember in the previous problem, we have asked to find out what is the population in year 1895. So this was an interpolation case. Okay. So this time what we will do, we will use some different year, and here let us try to find out what is the population in year, say, 1925. Okay, so if you see, this 1925 is lying within the data set. Okay, so that's why this will be called as what, interpolation or extrapolation.
Interpolation.
Yes, this is the interpolation case. Okay, so let us start with the problem. So here, first of all, we need to find out the value of p. Okay, so the value of p is nothing but the x minus xn, or let me put a small x over here, divided by h. Okay, so h is the distance between two consecutive values of x, and as you can see, the distance between two consecutive value is nothing but your 10 years. Okay, so here in the denominator we have 10. X is nothing but this value. Okay, जिसका population हमको निकालना है. So this is nothing but your 1925 minus xn. So xn is nothing but the last value of x which is available in the data set. So this is that last value. Okay, that is 1931. Okay, so now can anybody tell me what will be the value of x, please? Oh, sorry, what is the value of p?
Minus 0.6.
Minus 0.6. Okay, so this part is done. So if you refer the equation, out of which now we have the value of p, all we need to find out what are the delta value, that is delta yn, delta square yn, delta to the power 3 yn, and so on. Okay, so for this purpose what we have to do is we have to draw a table. Okay, so let me draw a table for you. Okay, so this table I have drawn. Okay, so here let us say we have x, and here we have y. Okay, so x values is 1891, then 1901, then we have 1911, 1921. Okay, 1931. Okay, and then your y values are nothing but 46. Okay, 66, then 81, then 93, and then lastly 101. Okay, so last time if you remember, here we have written delta y0. Okay, but this time delta y0 will not be there, it will be delta yn, and here this will be delta yn. Okay, so just to make it simpler, what we are going to do is, for the backward method, we are going to write down all the equations at the bottom. Okay, so here if you remember, we have here in the earlier case we have written 66 minus 46, isn't it? The same values we are going to write down here also, but I am writing down it from the bottom. So here I am going to write down 101 minus 93. Okay, how much will be this? Can anybody tell me? Yes, students, this is 93. 8. Okay, now here this will be now 93 minus 81. How much will be this? 12, not 8, isn't it? And this will be 81 minus 66. How much is this?
15.
15. And lastly we have 66 minus 46. How much is this? 20. Okay, so you see, we got here delta n as 20, 15, 12, and 8. If you refer the previous numerical, we also got the same values 20, 15, 12, and 8. Only thing is I have written them from the bottom, not from the top. So this table remains exactly same. Only thing is, just for sake of understanding, I am writing it on the downward side. Okay, so now the next value which is available, which we have to calculate, is delta square yn. So this will be also remaining same. So this will be 8 minus 12. Okay, so this comes out to be, I think, minus 4. And then we have, that is 12 minus 15, which comes out to be minus 3. And then lastly we have 15 minus 20, so this comes out to be minus 5. Is it right?
Yes, sir.
Okay, and then we have delta to the power 3 yn. So here you will have something like minus 4 minus of minus 3. How much is this? I think
Minus 1.
minus 1,
Minus 1.
right? This will be minus 3 minus of minus 5. How much is this? 2. Okay, and lastly this will be minus 1 minus 2. So this is going to become minus 3.
Minus 3.
Okay, so you see, the table which we have obtained earlier, this was also minus 3, this was minus 1, this was minus 4, and minus 8. So these are the last values. Okay, so the same table you will find over here. Now in the previous one we have used the first values because it was the forward difference method. Now in the backward difference method we have to use these values, that is the last values. Okay, so this is also one of the major change in the backward difference method. Okay, so I'm making this as bold. Okay, so now all we have to do is just substitute the values. Okay, so your y value. Okay, so let me write down over here, this will be capital Y. Okay, capital Y now can be written as yn. Okay, plus p into delta yn plus p into p plus 1 divided by 2 factorial into delta square yn plus p into p plus 1 p plus 2 divided by 3 factorial into delta cube yn. I think the last value will be delta to the power 4 yn. Okay, so we have one more term. So here you will have p is equal to, sorry, p into p plus 1 into p plus 2 into p plus 3 divided by, now you will have 4 factorial into delta to the power 4 yn. So now all we have to do is substitute the values. Now yn is nothing but the last value of y. Okay, so this is the last value of y. So here I'm just going to substitute over here as 101. Okay, then p value. So p value just now we have calculated. So the value of p is 0.6, which is negative. So I'm going to put this as minus 0.6. Okay, into, you have delta yn value. So delta yn value is nothing but the, you have to refer to this particular column and you have to see the last value. Okay, so the last value over here, it is 8. Okay, plus the value of p is minus 0.6. Okay, into minus 0.6 plus 1 whole divided by 2 factorial is 2 into 1 into, this is last value of delta square yn, which is, this is minus 4. Okay, so this will be minus 4 plus. Okay, so plus we have p, that is minus 0.6. This will be minus 0.6 plus 1. This will be minus 0.6 plus 2 whole divided by, now you have 3 factorial, sorry. Okay, into, you have now this value, that is minus 1. This is for cubical term, so this will be minus 1. And lastly you have minus 0.6, then minus 0.6 plus 1 minus 0.6 plus 2, and this is minus 0.6 plus 3. Okay, whole divided by 3 factorial, sorry, 4 factorial is 4 into 3 into 2 into 1. Here in case of 3 factorial, let me write down over here, and this entire thing, okay, so this entire thing will be multiplied by the last value, which is over here, that is minus 3 of this column. Okay, so this is multiplied by minus 3. Okay, so can you give me the value of y please now?
96.8368.
Yes, somebody please cross check this.
Yes, sir. 96.8368.
8368. Okay, so this will be the population of the given location at an year 1925. Okay, I hope this method is clear to everybody now. ठीक है?
Yes, sir. Yes,
Are
sir.
there any queries? It is exactly same as the previous one. Okay, that is the Newton forward difference method. Okay, so let us continue, and let us take one more numerical, and this time the numerical will be slightly bigger one. Okay, so you have to work hard on this. This is example 2. Okay, now in this example the data set is slightly large. There are some 9 data sets, no sorry, 7 data sets. Okay, so now we have something like x, and we have y over here. The data set starts with 3, then 4, 5, 6, 7, 8, and 9. Okay, so the values of y are like 2.7, then 6.4, then 12.5, then 21.6, then 34.3, then we have 51.2, and lastly 72.9. Okay, now in this particular case you need to interpolate as well as extrapolate the values. Okay, so in the previous problem we have done for the interpolation only. Okay, so in this class, in this numerical, let us go for the extrapolation case. Okay, so okay, so this extrapolation will be, so what will be the value of x? Okay, sorry, what will be the value of y? Okay, when x is 1. Okay, secondly, what will be the value of y when x is, let us say, 10? So if I talk about only 1, so it comes beyond the data set, and value of 10 also comes beyond the data set. In both the cases it will be called as extrapolation. Okay, so now for this purpose again you have to find out the values of p as well as the table. So what we will do, first of all we will create a table first, because table is uh, common for every case over here. Okay, so I don't know kitne tables lagenge, so let me uh, put a table which is like this. Okay, okay, so uh, we have now here x as well as y. Okay, and then we have like 3, 4, 5, 6, 7, 8, and 9. And this y values, again I will be writing down. This is 2.7, then 6.4, then we have 12.5, then 21.6, 34.3, 51.2, and 72.9. Okay, so now all you have to do is just find out the value of delta n. Okay, so uh, here you will have delta n. तो यहाँ पर क्या आएगा बेटा बताओ? Yes, anybody?
72.9 minus 51.2.
Yes, 72.9 minus 51.2. Okay,
21.7.
equals to how much?
21.7.
21.7.
7.
Okay, let me slightly expand this.
Are we supposed to make a graph for
No,
interpolation extrapolation?
no, not necessary. It is just for your explanation and understanding.
Okay, sir.
Okay, and the last value is there, so we have to make this as bold one. Okay, here what will be there? 51 point minus 34.3, isn't it? How much is this?
16.9.
Sorry.
16.9.
Okay, and here this will be 34.3 minus 21.6.
12.7.
12.7. Okay, this will be 21.6 minus 12.5. How much is this?
9.1.
9.1. Okay, and this will be 12.5. Okay, minus 6.4. How much is this?
6.1.
6.1.
Yes.
Okay, and this will be 6.4 minus 2.7. Sorry,
3.7.
3.7. Okay, and this is your delta n, so this value will be delta square n. Okay, so in this case this will be something like 21.7 minus 16.9, that is the next value. How much is this?
4.8.
Okay, so this is 16.9 minus 12.7.
4.2.
4.2. Okay, this is 12.7 minus 9.1.
3.6.
3.6. Okay, this is 9.1 minus 6.1. I think this
3.
is 3. Okay, and this is 6.1 minus 3.7. How much is this?
4.
2.4. Okay, so here since we are using backward difference method, so we will be using the last value. Okay, and then we have here delta to the power 3 yn. Okay, I think I have not written yn over here directly. I have written only this one. Okay, this is much better. So now here this will be something like 4.8 minus 4.2. How much is this? I think
0.6.
0.6.
All
Okay,
values will be 0.6.
is it so?
Yes.
Okay, so shall I write down directly? Okay, fine. And then we have delta to the power 4 yn. So now here this value will be 0, correct?
Yes, sir.
Okay, and the other values, this is delta to the power 5 yn, they will be also 0 and 0, and here this will be also 0. Okay, so basically this delta to the power 6 yn will be also 0. Okay, so now there is no point in writing down the complete equation. Okay, because this delta n values are already 0 at delta to the power 4. So usually how we write a expression? We write a expression with something like capital Y equals to yn plus this is p into this is delta yn plus this is p into p plus 1 divided by 2 factorial into delta to the power 2 yn. Okay, plus we have p into p plus 1 into p plus 2 divided by 3 factorial into delta to the power 3 yn. Okay, further it is not required because ultimately it will be multiplied by delta to the power 4 yn, which value is 0 over here. Then we have delta to the power 5 yn जिसका value भी 0 है, and plus we have something and delta to the power 6 yn इसका भी value क्या है? 0 है. So all we need to do is we just need to write a simple expression which is having only 4 terms, that is yn, this is one term, then this is delta yn, delta to the power 2 yn, and delta to the power 3 yn. Okay, so now let us try to solve the problem by this interpolation, sorry, extrapolation. So now I am interested what is the value of y when x value is 1. Okay, so now in this particular case, if you see the distance between the two consecutive values of x, it is nothing but
1.
1. Okay, so every time the h value is basically 1. Okay, now as far as your p is concerned, so now in this particular case when I'm talking about x equals to 1 only, so your p equation is nothing but x minus xn divided by h. So x is the current value जिसका y हमको निकालना है, so this will be 1 minus yn. Yn is nothing but the last value of y. Okay, sorry, xn. So last value of xn is nothing but your 9. Okay, so here this will be 9. Okay, let me use black color. So this will be 9 divided by 1. H value is 1, so this is minus 8. Okay, so now what you can do is you can rewrite this entire expression. Okay, this expression over here, so that we can get the value of y. Okay, so capital Y, now this will be yn. What is yn? Yn is nothing but this value, that is 72.9. So this is 72.9. Okay, plus p value. P value is minus 8 into delta yn. So delta yn is this value, that is 21.7. So this is 21.7. Okay, then we have p is minus 8. This is minus 8 plus 1 divided by 2 factorial is 2 into 1 into we have delta square yn. This is nothing but your 4.8. Okay, plus lastly we have minus 8. This is minus 8 plus 1. Okay, minus 8 plus 2 divided by 3 factorial is 3 into 2 into 1 multiplied by we have delta cube. Okay, so delta cube is nothing but 0.6. Okay, so here we have 0.6. So can anybody tell me what will be the value of y? 0.1. Someone please cross check this.
Yes, sir, 0.1.
सबका आ रहा है 0.1. Okay, that's good. Okay, now the second part of the problem says what will be the value of y when x equals to 10. Okay, so this is what we have written over here. So again you will find that x equals to 10 is beyond the data set. So now in this particular case your h is going to remain same, that is 1. Okay, your p value is nothing but x minus xn divided by h. So your x value is 10, xn is 9, this is 1, so p value is going to become 1. So the same expression, okay, the one which we have written earlier, the same expression has to be written over here. So finally this y can be written as 72.9. okay, plus this p value is nothing but 1, this will be 21.7 plus, so p value is 1, this will be 1 plus 1 divided by 2 into 1, this will be 4.8 plus p value is 1, so this is 1 plus 1, 1 plus 2 divided by 3 into 2 into 1. Okay, into this will be 0.6. So can anybody tell me कितना आ रहा है? 100. सबका आ रहा है 100?
Yes.
Okay, so I'm sure that this method is now clear to everybody.
Yes.
ठीक है, now I'm going to give you one small problem. Remember we have solved this problem earlier in yesterday's class. This was a population of a year. Now when we have solved this problem, we have used the x value as 1895, and for 1895 we have obtained the population of that particular location is 54.8. Okay, so this was using the forward difference method. Now I want all of you to again solve this particular problem, okay, the same problem using the forward difference method, and try to find out what is the value of this population in 1895. Okay, same problem, this is 1895, same data set, or you already have the table, so you don't have to redraw the table one more time. all we have to do is just change the value of P and give me the value of population. Please do it. Everybody please do it. Yes students. इसका आया? Yes, anyone?
सर सेम आ रहा है 54.8528 आ रहा है.
आ रहा है ना?
हाँ सर.
Okay, that's great. Okay, because if you see in the previous class, it was 54.8528. Is it the same value? Okay. So whether you use this method or that method, your answer is not different. Okay, that's why I have written this with this one with the backward, okay, and this one with the forward. Okay. Okay, so in both cases the answer is same. So we can use either forward difference method or maybe backward difference method. There will be a very small change, okay, but mostly the answers are correct whether you use this method or that method. Okay, now I hope all both the methods are clear to everybody, forward difference as well as backward difference. Okay.
Yes sir.
Okay then, so we will stop over here. Okay, very soon I'll be posting you the assignment for this method also, so please submit within the time. Okay. Okay,
Yes.
are there any queries? Otherwise we can stop.